Hi everyone, in this video we're going to learn how to linearize data. What that means is that we are going to create a linear graph from something that is nonlinear in the beginning based on the data we had collected in order to make a mathematical model that makes more sense. So first thing you want to do is make sure you title your spreadsheet based on whatever lab you had done, and in this video I'm going to keep our titles and labels generic so you could use this again if you had to. So we'll say this is Lab B. That way you can file your folders in your Google Drive and be able to find them a lot easier. So if you had to go back to find it later, you could find it quickly. We're always going to input our data with independent variable as our x variable or x-axis variable. We'll also want to include our units on there. Our dependent will go on the y. And so you can see here we have an XY t-chart that we're going to form for our data. Most likely you will need to take average values from your trials to come up with your dependent information. Let's pretend that these were the numbers that we had collected. Then we're going to go ahead and pretend that we were going to go and put in our chart. And remember, we will always select a scatter plot. And you definitely want to check that your x-axis and series, which is the y variable, are getting put in on the right spots there. So double check this area. Sometimes for some reason on Google Sheets it will put them both under the y or the series chart, and that's going to mess with you. Also remember, unless you see the vertical lines over here on the graph, it's not actually graphing your data points, and you need to go to the Customize tab. Under the horizontal axes bar, you can pick, or unpick I should say, treat labels as text. So you want to unclick that and you're going to see some vertical lines pop up in your chart, and that should show you that it's actually graphing. Remember, you can also force your minimum value of 0 so you can see the y-axis. So if I am looking at my data here, I got a nice graph made. It has my title, it has my y-axis label, my x-axis label, and all my points plotted. But if I went to insert a trend line here, which was under the series tab, I start to notice that my data points don't look so linear. If we were just to use this as a linear plot, we would probably end up in trouble if we were trying to solve for something above 15 or something close to the y-axis here, because this line doesn't technically represent all of the points. If you notice, the points on this end are below the line and this end are below, but the points in the middle are above the line. We're actually noticing a curved trend here, something that would maybe follow more of this path. So what we need to do is linearize this information, and that's kind of our new term here, and we haven't had to do that yet. So we're going to actually remove this trend line because we don't want it. We will need to manipulate our data in order to get a graph that will be linear, and I'm going to kind of show you how to do that. We've all taped in a reference sheet in the back of our notebooks that will give us a clue into how to linearize some information. It looks something like this. Sorry, I'm kind of zoomed in here on it so you can see. And what we want to do is first look through the 4 different columns and try to find the graph shape that represents the data we had actually collected. So if we looked through the list here, we find the one at the very bottom looks like the one from my data. Notice you could have a lot of different sorts of trends there. This is the one that looks closest to the one that we just graphed. And it says the square of y is proportional to x. And then in the third column, it suggests modifications needed to linearize the graph. So this tells us we need to graph y squared versus x, and that our equation is going to be a y squared equation instead of just the regular y equals mx plus b. So if we go back to our graph here, I'm going to actually move this down because that's the original graph. But now it wants us to square the y values and regraph the information to linearize. So I'm going to go ahead and just copy my x information over to another column, and then my y information, the dependent information, is all going to be squared. So I'm going to retitle this the dependent variable is actually squared and the units are squared. Whatever that would be for your lab, you would need to incorporate there in the title. You don't want to keep the title the same because you're completely changing the numbers that are going to go in this column here. So one tip that you can use is to insert a formula into Sheets, and how you do that is you click on the first box you want to calculate, you hit the equal sign, you can come back, click the box that you were originally using for that data point. We want to square the y values, so we can put the little caret and a 2, and it squares it for you. The nice part is, once you do it one time for one box, you don't ever have to do it again. You can come over, click this little blue box, and drag down, and it automatically calculates all of your data points for you. Then we can go ahead and insert our new chart. Once again, we want to select a scatter plot. We want to verify that our x and our y variables are going to be graphed in the right locations. We also will need to go back and unclick the treat labels as text box so that it will give us a nice graph. You can also set your min x value to 0 so you can see that y-axis. And now looks like when we graph, we get a nice linear plot. So we can go ahead and insert our trend line under Series tab. Remember, the trick to get your equation is to scroll just a little further and go to the label, hit Use Equation, and it pops up with our equation there. So for the graphing and linearization purposes, that's all we need to do. Now to create our mathematical model, we're going to use that equation. So remember, this is a y squared graph, so we'll call this y squared equals 4x, and then our y-intercept there is pretty negligible. You might not always have something that small. In a case where your y-intercept is significant, you're going to want to include that as the plus b value. But remember, from here, we are going to have to convert our variables into something that makes sense for the experiment, and we're also going to make sure we put in our units for the slope and y-intercept. So here, what this really is the dependent variable squared. So depending on what your dependent variable is, you could pick your symbol for what your y is. We're going to include 4. And our units for the slope in this case are going to be units of the dependent variable squared divided by the units of the independent variable from the x column. And then you're going to change your x variable to whatever your independent variable is representing. Remember, if you were to include your y-intercept, in this case it's negative 0.07, pretty negligible. You would also want to include your units, and remember, for a y variable here it's going to be a unit squared. And that's it. Ask me if you have any questions.